Aural perception is vital to immersion and realism in virtual environments. Acoustic phenomena that are important include diffraction, early and late reverberation, and scattering. Recently, interactive geometric simulation of sound has become practical in virtual environments. Additionally, numerical wave-based simulation has become possible for pre-computing large acoustic domains. Diffraction occurs when waves bend around obstacles when the dimension of the obstacle is comparable to the wavelength. This allows listeners to hear sounds not in the line of sight. Reverberation is the phenomena of successive reflections or echoes as they diminish in intensity. Reverberation gives a listener an idea of the size of an environment. Longer reverberation times roughly correspond to a larger or more reflective environment. We are interested in studying the effectiveness of accurate and approximate simulations of these phenomena in virtual environments. 16 subjects participated in our diffraction study. The experimental setup consists of 19 listener positions and a low-pass clip of a ringing bell as the sound source. The first listener position received direct sound, but the remaining ones only received diffracted sound. At each listener position we used two different methods of diffraction, wave-based and UGD-based diffraction. Walls were made fully absorptive so reflections would not impact the result. Subjects were blindfolded for the study. Participants were then asked to rate the loudness of the sound at each listener position and diffraction technique. Twelve subjects participated in the study. The setup consisted of 7 cube-shaped rooms of increasing volume. The source position was near the center of each room and comprised of a male voice. The audio was rendered using two different reverberation methods, an accurate geometric acoustic system and a standard Schroeder reverb filter. The subjects were allowed to move along a straight path in the room, with the length of the path being the same for all the 7 rooms. Subjects were asked to rate the size of the room using a dimensionless number depending on how big they thought the rooms were, based on the audio heard. Subjects were allowed to move around in the room as long as it took for them to come up with the number. The walls of the room had the same reflection characteristics as that of gypsum board. Subjects were blindfolded for the study.
Language, infinitely many words can be written with a small set of letters. Language, infinitely many words can be written with a small set of letters. In arithmetic language, infinitely many words can be written with a small set of letters. Language, infinitely many words can be written with a small set of letters. Language, infinitely many words can be written with a small set of letters. In arithmetic language, infinitely many words can be written with a small set of letters.